Hi everyone, and welcome to the Learning Curve. This video represents a continuation of my series on quadratic equations. And in this video, I'll be focusing on solving quadratic equations using the method of completing the square. So here we are told that this quadratic equation, which is in standard form, x squared plus 8x is equal to 7. We want to solve this for the values of x. The first thing you want to do when you're solving a quadratic equation using the method of completing the square is to identify the value of b. That is the coefficient of x in the middle of the quadratic equation here, which is 8. So b is equal to 8, and once you've identified b, the next thing you want to do is to divide the value of b by 2. So b will give you a value of 4. Next, I'm going to do some manipulation of this quadratic equation. So I'm going to express it as x squared plus 8x. I'm going to subtract the constant of 7 here from both sides of the equation so as to leave the variables on the left side of the equation and get the constant on the other side, on the right-hand side of the equation. So in effect, I will get x squared plus 8x equal to negative 7. Right? Because when we take 0 minus 7, of course the answer is going to be minus 7. So we end up with x squared plus 8x equal minus 7 by subtracting 7 from both sides of the equation in order to re-express the quadratic equation that we were originally given, which was in standard form. Now the next thing we want to do here is that we want to square the b over 2. Now b over 2 was 4, yes? So b over 2 is equal to 4. So when I take b over 2 all squared, I get 4 squared. And 4 squared here gives me a value of 16. That's the next thing we want to do. And then we're going to use this 16, which is positive, and we're going to add it to both sides of the quadratic equation. So this becomes x squared plus 8x plus 16 on the left hand side of the equation, and on the right hand side I'm going to have negative 7 plus this same 16. When we simplify this, this becomes x squared plus 8x plus 16. That is already in its simplest form because the terms here are all unlike terms. And on the right hand side, when I take negative 7 plus 16, we're going to get 9. So this is a simplified version of the quadratic in its rewritten form. So now we're going to identify the factors of the left hand side here of the equation, which is x squared plus 8x plus 16. And this is very important at this stage, which is why I had singled out the b over 2 value here. The b over 2 value was 4. So what you're always going to do is that you're going to end up with the factors of the rewritten form of the quadratic equation. The factors are always going to be x plus or minus whatever b over 2 works out to. So b over 2 worked out to be 4. So when I simplify the quadratic at this point that we're at, having squared b over 2, which is 16, and added that 16 to both sides to get to this point, then the left-hand side, we will need to determine the factors of the left-hand side. And the factors of the left-hand side are basically always x plus or minus, depending on whatever the b over 2 value is. In this case, it's positive. So the left-hand side is the same as x plus 4 all squared. And that is equal to 9. So x plus 4 all squared essentially represents the factors. X plus 4 and x plus 4 represents the factors of x squared plus 8x plus 16. Now, if this 4 here was a negative 4, then the factors would have been x minus 4 all squared. But because this 4 is positive, then the factors are x plus 4 all squared. In other words, x plus 4 times x plus 4. And these are the factors of the quadratic, x plus 4 all squared. Whatever value you get for b over 2, then the perfect square, the aim of the left-hand side is to really form a perfect square. So the left-hand side is always either going to be x minus b over 2 all squared or x plus b over 2 all squared, depending on whatever b over 2 works out to. In this case, b over 2 has a positive value of 4, so therefore it means that the perfect square representing this quadratic equation in the rewritten form would be x plus 4 all squared. If this answer was a minus 4, it would have been x minus 4 all squared. So what we need to do now to solve for x is that we need to try to get rid of this x squared. We need to get rid of the power of 2 on the left-hand side of the equation. And to get rid of that power of 2 on the left-hand side of the equation, what we're going to do is that we're going to take the square root of the left-hand side of the equation. Because when we take the square root of a term that is squared, it gets rid of that power of 2. And what you do to one side of the equation, you have to also do to the other side. So I also have to take the square root of the right-hand side, which is the square root of 9. When I take the square root of x plus 4 all squared, we end up getting x plus 4 alone, because the square root of x plus 4 all squared results in the cancellation of the square here, so we're only left with x plus 4. And the square root of 9 is 3. Square root of 9 is 3. So now we can easily solve for the value of x, and by the way, this will be plus or minus 3 because we're taking the square root of a constant. So strictly speaking, we would say the square root of 9 here is plus or minus 3, right? Because we're taking the square root of a term here. When you take the square root of a term, the answer is always going to be plus or minus whatever the actual root is. Because if I square negative 3, I'll get back 9 here. And if I square positive 3, I'll still get back 9. So that is why the plus or minus is important. So my final answer, I will need to derive 2 results here for x, which is typically the case for quadratic equations. We'll have 2 solutions, provided that the solutions are real. And so x here would be equal to positive 3 minus 4, because I will basically minus 4 from both sides of the equation to get x on its own. So one solution that I will have here, which I will call x1, is 3 minus 4, which is negative 1. And another solution that I will get here, which I will call x2, is negative 3, because there are 2 possible values for 3 here, a plus 3 or a minus 3. So the other solution that I will get is minus 3 minus 4, because we would, same process, we would subtract 4 from both sides of the equation. So x2 here works out to be negative 7. So that the solutions to this quadratic equation using the method of completing the square would be x equals negative 1 and x equals negative 7. So that's how we apply the method of completing the square. Now let's illustrate it with yet another problem. So here I have x squared minus 6x plus 5 equal to 0. And we're going to solve this quadratic equation by the method of completing the square. As I indicated previously, you first want to identify the value of b, which is the term in the middle that is multiplied by the x. And here b is equal to negative 6. Then I want to take b divided by 2. Always divide b by 2. And then b divided by 2 here would be negative 6 divided by 2. And negative 6 divided by 2 is going to give me negative 3. Very important result there, negative 3. And what I'm going to do is that I'm going to now rewrite this quadratic in the form x squared minus 6, keeping the variables on the left side of the equation. And we're going to minus this 5 from both sides of the equation. So it will be gone on the left side, and on the right side I'll just be left with negative 5, because 0 minus 5 is minus 5. So we must rewrite the quadratic equation in this form, and when we rewrite the quadratic equation in this form, with the variables on one side of the equation and the constant on the other, the next thing we want to do is that we want to square b over 2. So b over 2 all squared, which is the same as negative 3 all squared here, is going to give me 9. So what we do with this squared result for b over 2, which is 9 in this case, is that we'll add it to both sides of the equation. So I'll get x squared minus 6x plus 9 equal also negative 5 plus 9. Yes. So when we simplify this, we get x squared minus 6x plus 9 equal negative 5 plus 9, which is going to give us 4. Our next aim is to find the factors of the left-hand side of the equation for this newly formed quadratic, which is x squared minus 6x plus 9. To find those factors, what we're going to do is that we're going to just look at the value that we got for b over 2, which is negative 3. And so the factors are simply going to be x minus 3 all squared. This is always how you're going to derive the factors. Always. It's always either going to be x plus b over 2 all squared, or x minus b over 2 all squared, depending on the value of b over 2. In this case, the value of b over 2 is minus 3, so we just say x minus 3 all squared. So we have achieved the objective of getting a perfect square on the left-hand side of the equation. That's exactly what we want to achieve. And that perfect square, x minus 3 all squared, represents the factors for x squared minus 6x plus 9. In other words, there are repeated factors, x minus 3 and x minus 3, for this quadratic equation, x squared minus 6x plus 9. And this is equal to 4. And then now our aim is to try and solve for x. So to solve for x here, we are going to try to get rid of the power of 2 on the left-hand side here of the equation. And to do that, we're going to take the square root, because the square root will get rid of the power of 2. So we're going to take the square root of x minus 3 all squared. And what we do to one side of the equation, we have to also do to the other side. So this will be the square root of x minus 3 all squared, which is going to eliminate the power of 2. So I'm left with x minus 3. And of course, the square root of 4 is going to be equal to 2. Remember, when you're taking the square root of a constant, the answer is always going to be plus or minus that value. So this is really plus or minus square root of 4, which is going to give us plus or minus 2. Again, because if I square negative 2, I will get back 4, and if I square positive 2, I'll still get back the 4. So there are two possible answers for this. So therefore, I'm left with this. X minus 3 will either be equal to positive 2, or, this is just another way of expressing it, or x minus 3 is equal to negative 2, as we illustrated before. So now we're going to solve for x here. X would be equal to 2 plus 3. Because the 3 is negative here on the left side of the equation, we're going to add 3 to both sides to get rid of that negative 3. So we end up with x equals 5 as one of the possible solutions. And on the right-hand side of the equation, same process applies. We're going to add 3 to both sides of the equation to get x on its own. So x would be equal to negative 2 plus 3. And negative 2 plus 3 is going to give us 1. So the possible values for x are 5 and 1. And these represents the solutions to this quadratic equation using the method of completing the square. Thank you very much. I hope you found this to be very informative. and my series on quadratic equations will continue. I'll be looking at more problems on completing the square where the coefficient of x is not 1, as in this case. As in the case of both questions that I worked here, the coefficient of x squared was 1. In situations where the coefficient of x squared is not 1, we have to try to get the coefficient of x squared to be 1, and you will see how we deal with those situations in my next video as I continue this very important series on managing and solving quadratic equations. Thank you everyone. See you soon.